Hello, everyone. Welcome to the DNSSD working group session, and welcome to the final session of the IETF week. So hopefully you're in the correct room. I will take you through what we've planned to cover today. And a reminder, as you know, this session is covered by the note well, and so all of those policies apply. If you haven't read them, please do, because you need to be aware of them. And please sign into the session. We're currently showing 20 people signed in. If you're in the room but haven't done it yet, please do so. And any questions you want to ask, please join the mic queue, which you can do using the relevant symbol in the Meet Echo. So we are your chairs. So I'm Chris, and this is Florian. You can contact us if you need, if you have any questions, or if you want to discuss anything to do with the working group. We will require a note taker. Do we have any volunteers to help the working group by taking notes for this session, please? So we can't proceed unless we have a note taker. Note taking's a relatively simple job. You just have to note down the major points that were discussed. And it's a good way of helping. Remote participants also eligible for note taking. So just post in the chat if you would like to contribute in that way.
So Eric being the responsible AD for this, we cannot start without a minute taker, right? So we need simply to take basically the question and the answer or action item. So beside the first part, which is there could be some interaction, there should be a really, really easy job to do. And the chair cannot do it really. And you can be multiple of you doing it, right? And if you make a mistake, that's okay. That's a nice way for newcomers to the IETF that I'm looking, a good way to go. Thank you. You'll be added to that. It's free.
So, so please, who was the volunteer? I didn't catch your name. All right, just yeah. All right, thank you. So hopefully you can find the chat in the Meet Echo client, but if not, that's the link. Here are some useful links that point you to information about the charter of the working group and the documents that you are working on. The DNSSD has a GitHub organization where we store our working group documents. If you have a draft, you can contact the authors to get, sorry, you can contact the chairs to get set up with that. So this is what we plan to cover today. So the first part is we want to spend a good amount of time discussing the latest changes that were made during the editing process. Essentially all the changes that happened after SRP and update release left the working group, because the text that we've ended up with is, it has quite a lot of changes compared to what the working group sent out. So I feel it's important, well, we both feel it's important for working group to get a sense of what those changes are, to agree them, so that we can give a thumbs up before we before we get those published and they're set in stone. Once we've done that, we will cover these other items. So multiple queue types, which is quite exciting as we had some actual implementations of that. And we can talk about what happened there and the latest status of that draft. Esko is going to give a presentation to illustrate the use cases that he can see for time since received and what some of those corner cases are. We'll then go on to Ted giving us updates on not just TSR, but advertising proxy and SRP replication. And then finally, Gautam's going to tell us about using Service B with DNSSD. So any requests for changes to that agenda order? Nope. Okay, let's move on then. I've got these links. They're in the chair slides. I also shared those same links on the mailing lists previously. So those might be useful to you during the next section when we are discussing those changes. But we do have a separate deck on that. So Stuart, do you want to come up? Thank you. Yeah, so you need to share.
Do we have a working clicker?
We do.
Excellent, thank you. Okay, let's get into it. We have been working on these documents for a long time, and now they've gone through the whole process to Auth 48, and this is something that is not too unusual, unfortunately. When the professional writers of the RFC editor's office get to work on a document, they make a bunch of changes. And in my experience doing this many times, it's fairly consistent that roughly a third of the changes actually improve things and fix grammar and commas in the wrong place and all of that stuff. And I appreciate that. About a third of the changes are kind of 50-50. I don't care, but it's not worth fighting about. And about a third of the changes are completely wrong. And if we publish the RFC that way, it's really bad because it's changed the meaning of what it says in quite substantial ways. So it's really important to do a thorough review in the Auth 48 process. And in the course of doing that, we made a few changes, and in an interest of full transparency, we wanted to give the working group visibility into that. You can do a diff on the documents and you'll find an awful lot of changes, and most of them are just capitalization and minor word changes, spelling changes. I went through and I looked at all the diffs, and I hope I got anything that's not just a punctuation or minor wording change. Section 5.2 talked about renewing a registration at roughly 80 to 85% of the life, which is great. And then it says nothing about what if it doesn't work. Now, everybody in this room and everybody at the IETF is familiar with writing protocols, right? We have retries, we have exponential backoff. This is just absolutely common network protocol design, except it doesn't say that. So at this stage in Auth 48, I'm not going to be adding new normative language about must do this or that, or insisting on a particular strategy for retransmission, except I felt having reread the whole document from start to finish, which is another thing that happens when you're working deeply on a document and incorporating feedback from people. It's a change here and a change there and a sentence here, and the document becomes a patchwork. And when you actually take the time to read the whole thing from start to end and see how it flows, especially if it's been a while and you've forgotten the details, then That's actually better because now you're reading it kind of like a newcomer would read it. And there the inconsistencies really leap out at you. And I saw this gap where it said you should try it 80%, and then I was expecting the next paragraph to say, and what next? And it didn't. So if this was earlier in the process, I would have written something a lot more prescriptive, but it's not. So I just wanted to fill in this gap. And basically, I've highlighted the key phrase is it should have a reasonable retry strategy. I said, for example, you could try 10 times spaced equally, but I'm not saying anything more definitive than that. But I felt like that was an admission in the document to say nothing about what to do if there's a packet loss. So hopefully that's not controversial. Eric has a comment. Okay, let's take comments as we go through. We don't need to save them.
Yeah, okay,
end.
so
Go ahead.
It's basically Eric, individual contributor here, but knowing my ISG peer, if you ever should, without explaining, if you don't do it, what will be happening? But it's what you're using in this case, right? But yeah.
Thank you. Yes, that's. Let me make a note. I get annoyed when people misuse the capital keywords inappropriately, and I'm guilty of that here. Right? This doesn't need to be a capital should. So yes, thank you. I'm just using the word should in the normal English language sense of the word, not the RFC sense. Okay, thank you. Another example of just inconsistency and contradiction in the document. Section 5.3 says the server must not increment the serial number, must not, followed by, but if it changes, the server must update the serial number. And I just read that. It's like, can you make up your mind, like must not update or must update? Which is it? So just a simple oversight. And I just fixed it by clarifying what I think we all mean. And that is the overarching theme of this presentation is I want to make sure everybody says, oh yeah, that's what we meant. You're not changing anything here. I just added, it must not increment the serial number if the operation doesn't change the zone. And then the following paragraph says, if it does change the zone, then you update the serial number. So nice and straightforward, I hope. This is a little personal style thing, but it is a change, so I want to highlight it. This style of writing is increasingly common in RFCs these days, and I do not like it. I think if you tell me you can read page after page of RFC text written in this style and actually focus 100% on what the document's trying to tell you, I think you're not being honest with yourself. And certainly for newcomers to the field who do not have all the relevant RFC numbers memorized, this is completely opaque. And it's just this mystery game, like thumb in the back of the document, going back and forth to the references to figure out what the hell it's talking about. So I spent a lot of time going through trying to turn this gibberish into actual English sentences that a human can understand. So this, assuming I got all the documents right, which is the other thing about references, right, is you can sometimes have the wrong RFC number and not even noticed because people don't have them memorized. But this, to me, is a much more readable way of saying the same thing. Anybody with a reasonable knowledge of DNS and UDP can read this and understand what it means, whereas very few of us have all the RFC numbers memorized. This is another example of inconsistency in the document. The document says that the upper limit on the lease time and the key lease are recommended to be 24 hours and 7 days respectively. And service may provide a way to change that if you want, followed by the lower limit is 30 seconds. And then as a reader, I was expecting for sort of symmetry with the previous paragraph, and it would say, and operators can change that if you want. And it didn't. And in that way, sort of the lack of that sentence was itself a statement that implies operators shouldn't be able to change the lower limit if they want to. And I can't see any justification for why that would be what we meant. So I added that sentence for symmetry with the previous paragraph. And I hope that's not controversial. it's a very weak sentence to say if the operator wants to shoot themselves in the foot, we should let them do it. And regardless of whether the document says that or not, an implementer could do it. So I just wanted it to be consistent. And then I think this is the last one. In the later rounds of editing, this might have come from IESG review, there was some text that said the server must enforce a minimum. And that makes sense as just part of general review that happens for the security considerations. But when I read it, it seems like it's not very actionable. It doesn't say what the minimum is. And it says that the server will silently ignore requests. But if it doesn't say the rules for when the server ignores the requests, then how do clients know if they're sending an update too fast? So if you switch from one Wi-Fi access point to another one and have to send another update 2 seconds later because your address has changed, that's not a flooding attack. That is just the protocol behaving. And if we need to have some hold down time that says to the client, you have to wait 5 seconds before you do another update, well, the client needs to implement that. But this doesn't tell the client what it's supposed to do to avoid tripping this protection on the server. So I felt like that was well-intended addition to the security considerations. But it feels like it was a minimal effort to address some concern that was raised and some words got put in. So I had a go at writing something that I thought would give some more actionable and probably better quality advice, which is we have documents that talk about how to resist flooding attacks. So this is my proposal is if your server is in an environment where it might be subject to flooding attacks, then here is some guidance for things you might want to do. Ted is at the microphone.
Ted Lemon. So I totally agree with this change, except I will point out that actually there's a really important motivation for this, which is that current Matter clients will send a delete before they send an add always to make sure that there aren't any stray service instances lying around from like before a reboot or something like that. And so if we were to sort of implement what this originally said, we would probably ignore the update that added the new service because it came too fast, because it came immediately.
Okay. So to repeat back what you're saying,
yeah.
If we were to implement this rate limiting right now, it would in fact break Matter products.
Correct.
We'd have to go back and change Matter products to put some delay in of some unspecified duration.
Yeah.
Or something.
Or something. Yeah.
Yeah.
I mean, or we, yeah. So.
Yes. So this, I think, is the biggest change, and that's why I'm bringing it to the working group's attention to make sure everybody thinks this is reasonable, helpful guidance for implementers. And that is the last one of that document, I think. Yep. Shall we move on to the next?
So just before we move on to the next one, so any objections or any thoughts on these changes, or are you totally happy with it?
Eric Vang didn't join the queue. Just to stress, this is a really important step. Okay, just to restate what Stuart and Florian and Chris had said. If nobody objects here, I mean, you will approve the Auth 48, I will approve the Auth 48, it will be published next week. This is really the last minute, right? It has been on the mailing list for a couple of days or weeks now. Last minute change, everyone is okay. We approve. Okay, we know what email.
That's what we're hoping for. We're not looking for trouble, but we want to make sure we're totally transparent. Thank you, Eric.
Change the should do.
Does anybody want to say, please give me until such a date to have more time to spend looking at it?
Matthias Kovac, Siemens. Sorry for not being on the queue. I'm just wondering, SRP is also over UDP, and there's now only text for TCP, which makes me wonder if the guidelines can be transferred or if there should be something about UDP as well.
If you have some suggestion for text to put in, we can look at that, but with the caveat that just like all of my changes, like in Auth 48, it's not the time to be making substantial changes. So here, what the text says is it's recommending to follow established industry best practices to guard against flooding. That is not talking specifically about TCP. And then there's a couple of references that if you're totally new to this field and don't know how you'd guard against flooding, reading those documents might give you some ideas.
Yeah, it was basically my question.
If you know a reference for like a similar RFC, a book, a blog post, if there's some good document that is like guidance for UDP implementers, I would happily add that reference. So we don't want to delay this any further. And my apology to the whole group is that I've been busy with other stuff, and this is very late. And when it came up for Auth 48, I'm glad that I didn't just ignore it and say okay. I actually took the time to read the whole thing, because I think I found a bunch of things that I'm glad that we fixed, because we'd be getting errata filed against this RFC if we'd not caught them at this stage. So I'm glad I finally did that, even though I'd been a little bit lax leading up to it.
Yeah, perfectly fine. I don't want to delay anything. It was more getting maybe the atmosphere in the room.
Yeah.
If they think this is a good pointer, that would also help for the UDP case. I don't have anything good from the top of my head.
All right. Thanks
Thank
for the
you.
input.
Mark, go ahead.
DNS vendors already do rate limiting for various things, so I'm not particularly worried about TCP versus UDP there. As for the meta devices, why aren't they clearing the buffers in the update in the first place? Updates can clear and add.
No, they can't. But yeah, sorry.
So maybe you can explain that, because I confess I see.
Yeah.
Right. You if you have a host name that had a bunch of services advertised before, like maybe they had SSH login enabled for debugging.
Right.
Then after a reboot, you want to wipe the slate clean, and SRP doesn't have a mechanism for that, right? When you like a host description can delete all the address records and then create the current set, and that has the side effect of cleaning out stale records.
Yep.
But there isn't an explicit operation that says erase all the services that are on this host and then make a new set. And
Correct.
maybe if we could go back in time, we might have added something, but we
Right.
didn't.
Yeah, it's an omission in the protocol spec that it's too late to fix right now, and nobody implements anyway, so it wouldn't help much. I should point out that my previous comment was actually about SRP, not about lease update or update lease. So in a sense, I'm not sure what we say in the SRP document about this. And the last thing was that I would say it might make sense to just clearly say flooding attacks over TCP and UDP, just so that people don't assume that because you're referencing TCP SYN that you mean only TCP flooding attacks.
I like that suggestion.
Yeah, I mean, you don't have to even cite anything. Just
that's a simple two-word change, and
Right.
it avoids confusion.
Yep.
Okay. Let's move on to the next slides. up to you.
Thank you. This is a similar 8 slides about the SRP draft. First change here, the document talks about rejecting an update with the YX domain R code. I think we all in this room know what that means. YX domain means this name already exists and you can't have it. So if you want to register a service, you need to try with a different name. The document didn't say that. I believe that's what we meant. I thought it'd be helpful to spell out that that's what we mean. And that is in contrast to the next thing, which is refused. And just like I was talking about with the previous draft, this was the result of reading the whole thing from start to end after a bit of a break and trying to make sense of what it was telling me. And it talks about what error codes the server should generate, and what goes hand in hand with that is telling the client how it should interpret those error codes. What do they mean? And having worked on this, I know what it's trying to say, which is YX domain means you can't have this name, but we invite you to try again with a different one. Refused means stop. Do not go into an infinite loop pounding the server forever, because you're never going to succeed. And the example where you would use refused is this text about offensive names. And if you have an offensive name, putting a 2 on the end is probably not going to make it not offensive. So, yeah. So this is illustrative about how clients should handle YX domain and refused differently. And this is important because it does happen in protocols that error handling is not done very well. And there are so many examples. One from years ago was some vendor of home gateways got their time from some university's NTP server, and they didn't have any contract, any agreement to use the service. They just put it in their firmware because, hey, the internet's open, it's free. And when the university shut that host down, millions of home gateways around the world went to an infinite retry loop, just attacking that address continuously and getting back a flood of ICMP host unreachable, and just basically retransmitting NTP requests as fast as it could. So if it is important for RFCs to say what you're supposed to do in the failure case to avoid those kind of accidental packet flooding attacks. So that's what this text is saying, is just to clarify in both places, YX domain means try again, refused means don't try again. Section 5.1 talked about times and avoids the possibilities of misunderstandings. And I thought, that word is doing a lot of hard work there. Like, what misunderstandings? What do we mean? So I tried to expand. What do we mean? We're talking about the race condition where we don't want the client to think the registration is still active when the server or the registrar decides it's expired. So I turn that one word misunderstandings into a little bit more spelling out of what I think we're trying to say, which is renew the thing before it expires, and specifically renew it a little bit before it expires, because clocks always don't run at the same rate exactly. There might be a 1% error in the clock rate. So have a bit of a safety margin, because and this is again a mistake I've seen in RFCs and other technical specifications, if you assume that clocks are always perfect, then you can make the mistake of doing very precise calculations that then don't work, because clocks are not perfect in the real world. So some acknowledgement that a drift of 500 parts per million is not unusual, and that's 0.1% error.
Ted Lemon again. So having written that text, I agree with you that misunderstandings is not sufficiently detailed to actually cause the reader to know what I meant. And this additional text is proof of that, because this is not actually what I meant. What I meant is that because we have an artificial idea of what time it is that is sort of constructed based on when we sent the packets, it's always going to be the case that when the client thinks the thing expires is going to be earlier than when the server thinks it expires in absolute numbers, because the client sent the packet before the server received it. They could happen to have the same wall clock time in seconds, which if the server is counting time in seconds would mean that they would agree, but that's unlikely. And both because they probably don't count in seconds and because, it doesn't always happen that way. So that was the point of this. It's not to say that the text you added is wrong or unhelpful. It's just that what I was actually trying to convey is just that the least time that we receive on the server is always going to end slightly later than the client expects it to.
No, I agree with that point. It's true. I think it's one of those necessary but not sufficient things, which is it is true that the server starts counting a few milliseconds after the client starts counting. But if you add in the subject to clock drift, that's another dimension here that could mean that even though things start off correct, they could drift and become incorrect later. So just to be 100% clear, are you happy with this text, Ted? Okay, that's a thumbs up for the notes. This is, just like I said for the previous document, the SP request to add reverse mapping, see some document and some other document. So I said IPv4 reverse mappings are in 1035 and IPv6 reverse mappings are in 3596. Just more turning RFCEs into readable English. And this is the last one. Don't know who to blame for this. Don't care. I'm not going to do the archaeology. The sample bind 9 configuration, which I put into my name server to test it in North 48, was just broken. Enough said. I believe I fixed it. Because I didn't understand key IDs, I didn't realize that the number in the comment was actually wrong. It's only a comment. That's why it worked. But we did get feedback, and I actually did a commit last night that fixed the key ID in the comment. So that is now correct. So I will not put all the text up on the slide. It wouldn't fit. But if you have any doubts about the sample configuration, firstly, why didn't you raise it before? But you can check what's in there now. I did put it on my name server and do the queries, and I believe to the best of my ability, it is now correct.
Thanks for doing that, Stuart. I raised my hand not to talk about this, but just to mention, because since you said you're at the end of the slides.
Last one, yep.
There's one thing that you haven't talked about that I think is actually quite important, which is that particularly in the update lease document, which is quite an old document. And so it's been around a long time and sort of was written when the standards were different than they are now. But also to some extent in the SRP document, there was a fair amount of confusingly inconsistent usage of terminology. And the RFC editor did a really good job of pointing that out and identifying the cases where it was an issue and asking us to fix it. And so there's a lot of changes strewn throughout the text that look like they're larger than they are because we had to change the terminology to be more consistent. So I just wanted to mention that if you're looking at the diff and you see all of that stuff and you see I think there was like DNS update, SRP update, stuff like there were just like 15 different terms for the same thing.
We talked about update message, right?
Exactly.
Just lots of different ways.
Yeah. So we did a really thorough effort to try to address the concerns that the RFC editor raised there. And particularly since we were sort of slightly complaining about the RFC editor, I wanted to give them credit for that because that was a very useful request. And I hope that it makes the document a lot more readable for newcomers. Yeah,
thanks for saying that, Ted. The RFC editor does do good work. That's why I started off by saying about a third of the changes are really positive. And I can say doing work in the IETF and other standards bodies, the quality of the documents we put out is head and shoulders above what most standards bodies put out, and that's because of the diligent work by the RFC editor team. And all of us here, of course.
Yes.
That's it for me.
Yeah. So same question as for update lease. Are you happy with this text being published as the official specification of SRP, or do you have any comments on what we've just gone through? Do you want more time to separately to look at this text and just give a thumbs up on the list? Yeah, please tell me what you think.
All right, thank you.
All right. Thanks, Stuart. So next up is multi-queue types. So Ray's coming up.
I'd better try and wake up. Okay, I haven't got any slides for this one. It's really quite brief. We had what I felt was a useful sort of development and interop at the hackathon at the weekend last, along with a little bit of work thereafter. I think the good news is the implementations appear to interoperate quite well. There were a few minor issues found in the implementation by Francois, but he's now resolved those as well. I've made some clarifying updates to the draft, which have just updated to -07 just a couple of hours ago. There's nothing really too substantive in that, except for, so they're all clarifying, but one specific clarification I've made at Stuart's request is some additional text that clarifies that recursive servers must go and find all of the Qt values from upstream servers if they don't already have them in cache. It was kind of implicit in the original text, but now it's explicit. Really, not a lot more to say on that. I still do plan to make at least one more update to take on board Stuart's comment about RFC references, which I haven't yet done that one because my brain's been too addled to try and do it. But apart from that, yeah, I think we've proven it works. There were no major flaws found in the specification, just minor clarifications.
Yeah, it's totally up to you if you want to do that rewording. It is quite time consuming because you have to think about how am I going to turn this into a sentence that a normal engineer could understand. I take the time to do it because I think it's a courtesy to the reader, but it's totally up to you if you feel like you've got the energy to do that.
Okay, thank you.
Unless you had more, but it sounded like you were kind of, okay, good. Tommy Jensen. So I was part of that hackathon. I can report that we got successful combinations of client and server working without really uncovering any spec bugs. The clarifications you added in the latest addressed everything that I had questions about before. And this looks awfully working group last call ready.
Yeah, thanks, Tommy. So I guess just put that back to the chairs, and when you decide whether you think it's ready for last call. And I've got nothing else.
Okay. Any more comments or questions on multi-queue types? Nope. So I think this is great progress. Yeah, it's good to have running code. It kind of gives us confidence that the design works and is also relatively easily implementable by anyone who wants to implement it. So that's a good sign. So I think it's likely we will, yeah, unless people tell us otherwise, yeah, we're probably proceeding towards a working group last call on that.
Yeah. Okay.
Yeah, I was thinking maybe we want to hear back from the actual implementer. So I know that Ted has some slides later on from the interop testing.
Oh,
so,
you did? Okay.
Yeah. And yeah, so just get some feedback on the list and then do the last call, I think.
Yeah. Okay. Thank you.
Okay, Esko, we're going to go to your slides now.
Okay. So how much time do you think I should use?
I think we're doing well, so yeah.
Okay.
At least 10 minutes.
So I think you also need to pass me control, right?
Here's the plus. Okay.
Yeah, that works now. Yeah, so I want to explain some use cases and also corner cases of using the TSR, time since received option, defined by this draft. So I think Ted will have a bit more to tell about the draft itself. So this is just some observations and some graphics to guide you through that. So I called it the TSR tutorial. I'm not sure how much that is needed here, but this is also a good check of my understanding of the specification. So this is a kind of drawing of a network topology where TSR is used in combination with other technologies. So here there are two snack routers, the blue boxes, and they also are 6-LoWPAN border routers. So they basically interface between a high-speed Ethernet network, the AIL, and the 6-LoWPAN mesh network. So each of these snack routers also has the SRP registrar in there and an advertising proxy. So that enables the SRP client on the bottom left to register their services with an SRP update, which then also gets announced on the AIL so that other clients there can also use those services. Okay, so far so good. Move to the next slide. Yeah, so here you see a situation of the same topology, but then at a later time, what happens. So you can see on the left, there is some link failure there. So that means...
Esko, we're losing you a bit.
Oh, sorry.
You might want to turn off video, I think.
Yeah, I can try that.
Okay, try saying
Okay,
something.
yeah. Yeah, so it's actually my Ethernet plug that just went out. Sorry. Restore it again. Can you hear me now?
Yeah, I can hear you.
Yeah, okay, perfect. So I was telling about the link failure here on the left, because the snack router, and well, that means it gets basically detected in the local mesh network because there is some form of network-wide configuration data that gets updated. So now it sees, hey, there is only that other router there with an SRP register. So I'll register there. So there's a fallback solution. So nodes that have services will register there. And that gets advertised on the AIL as well. And it's the same service at the same names because that did not change. And now you see here an MDNS probe and announce happening on the AIL with the TSR option in there. So there the time since received would be 0, for example, because it's just registered. And on the other side, it still has an active advertising proxy, basically, that sees that new data and compares the timestamps and then is able to remove the stale data there. So that's the idea how it should work, I think. So thanks to the TSR option, the new registration succeeds and does not fail because of a conflict. And also the older data is there automatically removed on the leftmost device. So I'll move to the next slide. This is the query situation. So you could have a client on the AIL that sends a query for the service and then gets an MDNS response there from the rightmost device only. So that one has the latest information, so that should be the one to respond here. And this also has the TSR option in there, and that's something that the client doesn't know about, so it would just ignore it, which is fine. Okay. Then there are some special cases that I thought about up for discussion. So this first special case is A, which is if the advertising proxy on basically device number 1, the leftmost device, what if it missed the probe announce coming from the device number 2? So if that happens, then the old state does not get cleared. So if an MDNS client queries, that might get 2 answers, old and new. And I have a figure to show that. Oh, that's the case B. Sorry, that's there's no figure for that. Sorry. So the point is here that the advertising proxy with the stale information may transmit earliest. So which means that the client who doesn't know anything about TSRs or advertising proxies gets basically stale information first, followed by a second response with the more updated information. So I'm not sure how worried we should be about this case. It will in the end resolve itself, but it could happen that this client then gets stale information.
Looks like Ted has a comment.
I think the slides disappeared.
So there's a couple of things that will happen when this particular issue occurs. One is that the server with the stale data should see the response from the server with the recent data, and it should clear that out of its cache. Even so, it might have missed the original announcement or probe, but it's still going to see the response. Now, of course, it could also miss that because we have a lossy network. That's why it didn't see the probe. But at least in principle, the data can get flushed out of its cache there. And when the client sees the new data, in principle, it should be able to use it. So if in fact the new data is if there's a difference, like if the IP address changed or the service advertisement changed or something like that, then what the client that's discovering the service will see is it'll see the information for the old service followed by the information for the new service, because a conforming DNS responder will see that the TSR value is newer on the second response, and so it'll flush the first response, which will cause that to be removed and then new information added. So I think it basically takes care of itself as long as everybody's implementing this. The challenge, of course, is that if the consumer of the data is not implementing TSR, then it may see these 2 announcements as just additional information. So.
Yeah, so I think the case is here that when let's say when the older data first responds, and then another party that has newer data will probably also send its response, right? Because that's kind of the authoritative data then. If the newer data responds first, then the older one will also kind of not respond, I'm guessing, right, Ted? So maybe you have to consider that, but I was assuming at least.
Yeah. What'll happen is that there's 2 reasons why it won't respond. One is because if it sees a response to the same query that it saw, it's not going to respond because the query's already been answered. And secondly, if it sees the response, it's going to flush its cache. On the other hand, if it doesn't see the response, then it'll send its answer later, which if the consumer of the data is not implementing TSR, it may see the stale data as being more fresh than the correct data, in which case we would actually have a problem. But again, this assumes that there's an issue with delivering these multicast packets, and in that case, yeah, things are going to fail. I mean, the network has to work to some degree.
Yeah. So my thought was there is no guarantee that basically a client that's a consumer of the data, that it will basically look at the second response after it already got the first response, right? Because maybe it just takes the first and runs with it. On the other hand, if the data is exactly the same, then there is no issue there. So if, for example, IP addresses are the same, then
so a client that doesn't use the new response is broken. Like, that's an incorrect implementation.
Yeah, I'm talking about the client that doesn't know about TSR, basically. So it's an MDNS.
But just an MDNS client in general.
Mm-hmm.
when you get additional data, you don't just like, keep
Ignore
using
it.
the old data. I mean, that's just broken.
Yeah. Okay.
So,
Yeah. So that should work then, in the sense that if we make sure that the device with the newer data sends it then afterwards, after the old data has been sent, then it should be fine, right? Yeah. Okay. I will just introduce special case B here then, which has a figure. So here we have the SAP client, which used to be in a mesh network on the left. It turns out to be, it can also attach to the AIL. It can be, for example, a mobile SAP client on a mobile device, so that has multiple network interfaces. So for example, if it's Wi-Fi, it could attach to Wi-Fi here. So basically the idea there was you get the cached MDNS response, which came from the time that the device was still in the mesh network. And there's also a response from the mobile device directly. So it's not proxied anymore. So it would not use the TSR option here. It just plain MDNS response without TSR. And again, this should work fine. I think only maybe there's a case when number 2, the proxy has missed the probe announce coming from the mobile when it joined the network. So that's basically a corner case. And in that case, the MDNS client who is looking for services might get 2 answers. And just like last time, I think after that, the situation should be resolved. And number 2, basically the advertising proxy marks the data as stale because it sees there is an authoritative source for the same data, for the same names. So it should basically remove its own set of data. Okay. And if there are no comments on this, I can move to case C, which is the last case. So we have A and B listed here just for convenience.
So I do actually have a comment.
Oh, you do have a comment. Okay.
Yeah. So I don't think that what you described is precisely what will happen. Can you go back to the the discovery proxy has, or the advertising proxy has a registration with TSR. It's advertising that registration. The client moves to Wi-Fi without doing anything to clear up what's going on in the advertising proxy. What we would expect to happen is as soon as the client connects to Wi-Fi, it's going to announce the service. And so this is independent of the MDNS client sending a query.
Right.
And so the service announcement should result in one of 2 things. And I can't actually remember what the TSR draft says. So you may be correct that the non-TSR response overrides the TSR response. I honestly can't remember. I suspect, though, that what actually will happen is that we'll go back to the usual conflict resolution strategy, which would be that the newcomer loses. And if that's the case, then what's actually going to happen, because remember, the probe is not an announcement, so it's not going to go into anybody's cache. So what'll happen is that the mobile device will send its probe, and it will get back a response from the SNAC router saying, no, sorry, you can't use that name. So I think a device that's doing this really should implement TSR, even though it's not a proxy. So this is a really interesting corner case that we probably need to talk about.
Yeah, right.
Because this is a special device, right? It's a little weird, and so it's not unreasonable to ask it to do some new behavior.
Yeah. Okay. Yeah. Yeah, it's special in the sense that it has these multiple network interfaces and can roam in this way. Yeah, so that's a good point. Yeah, about the probe. And in this case, yeah, the corner case basically was that it did send probe and did announce, but that SNAC router 2 basically missed that or was briefly offline during that period. Okay, so we can maybe create an issue for that and think about it. And then finally, I wanted to talk about case C. This is the last one. I think there's a typo in the slide. It says A, but It's basically C. So here we have multiple of these snack routers. So any number n, it could be, for example, n is 5 or 2. And they do replication amongst each other. So we also have SRP replication, which could be done between multiple devices. And yeah, they all basically serve here the same 6-LoWPAN mesh network. And the idea here is that replication could happen fairly fast, so within less than 500 milliseconds. So that basically means that if one device on the mesh network registers its service, it gets replicated, and basically the time since received for all these advertising proxies, all these n advertising proxies, is about the same. So if they basically advertise a service, in this case there's a query sent, and all the devices advertise or want to advertise the same service with TSR 77 here. So because they all have roughly the same number of seconds since having received the registration. So this looks like it could be a conflict in terms of time, and it could also be easily solved by doing the value in milliseconds instead of seconds, I think. That's just one thing to consider. And the field, we have 4 bytes. I think it's really more than enough to use milliseconds for that.
So, Esko, just to be super clear, time since received is time since it was received from the client. So we don't store that as a constant on the server. We store that relative. So we basically, on the server, on the SRP registrar, we store the timestamp when it was received. And when we send it over MDNS, we send the difference between the current clock time and that timestamp. Or actually not so much the current clock time as the current running time. So like in case the clock may have been changed. So actually what we should see is that the TSRs are always going to be the same in this scenario because it's replicated. So it is the same data. But if there's a subsequent registration by the client, then the TSRs are going to be different. And so it'll get invalidated. So it should work correctly.
Okay, yeah, that's maybe a different understanding of what TSR is. So you're kind of saying the original registration time from the client basically gets included in the data that is being replicated. Is that right?
That's right. I thought the document said that explicitly, but if it doesn't, we should fix it because otherwise this is totally broken. It just won't work.
Yeah. Oh well, it can be made to work in another way, I think. So you could consider basically the time since received from either a client or from a replication peer. Basically, that.
So you really can't, because bear in mind that replication can happen like 30 minutes later, right? So there could be a 30-minute time difference, and then we're going to invalidate valid data.
Right,
so
right. Yeah.
We really do need to know when the original registration happened. That's the only time that's usable.
Okay, thanks for the input. Yeah, it's a good point. I can maybe do a read of the document. I didn't read it completely, so maybe it's stated somewhere that this information is also replicated, because it was a long time ago I read about the replication draft. So, yep, okay. Thanks, it's now clear to me, so we can move on. So this was the last case, and now we have some follow-up to do on case B, I guess. And the slides are available if you want to browse through this. So thanks for your time.
Okay, thank you, Esko. Anyone got anything they want to raise? If not, we can move on to Ted's slides, which is a set of updates on adopted drafts. Yes. Well, you should do that.
All right. Thank you. So I basically just did one slide deck because there isn't a whole lot to say about any particular thing, but there's interesting things to say about a bunch of things. First of all, MQ type, I agree, is ready for last call. And in fact, I would really like to see an early allocation for the code so that we can actually sort of solidify the implementations. I did an implementation sort of in our code base, which is like the thing that sits in your HomePod Mini or whatever. It's on a branch somewhere, so I don't know when it's actually going to land, but it's done. There's a few things that I would tweak further based on the conversation that I've been having both with Ray and with Peter. But I was very happy with the implementability of it. I didn't run into any problems that I needed to solve in a serious way. I mean, you know, there were obviously, it's a little bit technically challenging to implement, and I had to add deduplication to my resolver because that wasn't super necessary previously. But it was totally doable. It works. I'm very happy with it, and I really would like to see OpenThread also implemented if anybody from the OpenThread team happens to be listening.
Yeah, thanks. So good mention of the early allocation. Yeah, I think I'd support that at this point. I don't see any reason why, if the chairs agree, that we couldn't actually go and ask Guyana to allocate the code points so that we can actually use those official code points rather than experimental ones.
Yeah, sounds good.
Yeah. I'm not quite sure what the process is. I think probably you as chairs need to actually ask
Yeah,
for that.
chairs need to ask.
Yeah.
So TSR, we had a presentation on TSR just now, but I had a few other things to say about TSR based on recent implementation. Oh, Florian, did you want to?
Yeah, I wanted to add something to the multi-queue types. So there was a bit of conversation in a side thread that was not on the list about the hackathon thing, and I'd just like to see that on the list. Like if Francois could say, "Oh, I did this," that kind of thing, and then we can just do the last call, I think.
Okay, so Francois, if you happen to be listening, I think he's probably up by now. Then you have been requested to also do a report to the mailing list. Okay. So moving back to TSR. So this is implemented. It's been shipping for a while. We've run into some issues with the implementation, and indeed the most recent update to the spec was a result of that. That was a while ago. So we ran into yet another issue recently, which during testing, which was kind of exciting. I'll talk about that shortly. I think the spec is pretty solid at this point. You know, ESCO missed, or possibly I missed, putting in the bit about what time we're recording. So we should make sure that that's correct. Also, we need a co-author, and I can't remember whether ESCO agreed to be a co-author or not. He did?
Yes.
Oh, excellent. I will add that. Okay, so great. So one of the
Sorry, just to jump in there. So I think ESCO, you were requesting to change the format of the document, weren't you? So I guess that.
Yeah, that's right. So I said it's fine, but it has to be marked down, or preferably if the working group agrees with that.
Complain. As you wish.
I guess you're not objecting to that.
That's fine. Whatever. Okay, so anyway, moving on to the so I have basically some implementation stuff to talk about. I don't know that this necessarily needs to be talked about in the document, but part of the reason that I'm telling the working group about it is so that you will be able to tell me what your opinion is. And part of it is just that, like, for avoiding extra multicast on the network, I wound up doing a bunch of sort of tricks to try to avoid sending announces and probes when not necessary. But there are still some open issues. And one particular thing is, so remember that my use case for TSR is SRP replication. With SRP replication, sometimes you have an SRP server that gets pulled out of the rotation for whatever reason. Maybe it's shutting down or whatever. We want to make sure it doesn't send goodbye packets and make services look like they went away when they didn't. So, and then, you know, announce packets and probes. We don't want extra announce packets. Obviously, we need probes when there's new data, but that ought to just mean that the server that received the update from the client does the probe. And once that server has probed and validated the registration, the other servers that get the service replicated to them should not additionally probe or additionally announce. That's just wasted bandwidth. And we know that multicast bandwidth is precious, so we do not want to do that. And also, another issue is that, I send out a query, and we have some randomization in the DNS spec. So the DNS responses will come out, MDNS responses will come out sort of offset by, some number of milliseconds. But it turns out that the number of milliseconds is shorter than the beacon interval of a typical Wi-Fi base station, which means that they all wind up coming out at the same time. And so the reason for spreading them out was so that, the first one that responded would win, and the others would see that response and not also respond. But now we're not doing that because of this. So one of the things that I'd like to add, and that's not in the current documentation, and probably, I don't know that this is necessarily a TSR specific thing, so I don't know that it goes in the TSR draft, but maybe it does, is that if you have multiple servers answering, you should coordinate, and one of the servers that's answering should answer first. And the next one that answers shouldn't answer until it sees a retransmission, because otherwise, we wind up with that situation where everybody replies. And so we have like 5 multicast replies if you have 5 SRP servers. And that's quite consuming of bandwidth. That's a lot of packets. So let's see, I already talked about probes. And we need to make sure that if a server goes offline and unpublishes its data, that it does not send goodbye packets unless there's no other server left, which isn't always going to be easy to tell. So, and I think we should probably err on the side of not sending goodbye packets rather than on the side of sending them, because the goodbye packet in the case of SRP is not particularly relevant anyway, because we don't actually know when the service comes and goes with SRP. We just know that it renews from time to time. So if we haven't heard from the service in a half hour, maybe it's still there or maybe it's not. Sending a goodbye packet, is sort of redundant at that point. We have to account for the fact that we might see a stale advertisement anyway. So, and then, the other thing is that when we get a renewal from a client, if it doesn't change anything, we shouldn't be doing another probe. It's just wasted stuff. So the focus here is to be as quiet as possible with our multicast. So those are the issues that I see sort of for the crossover between TSR and SRP replication. So what to do next? I think that we need to do another implementation. OTBR actually has an implementation, but it's of an old version of the draft. We haven't done a Connect-a-thon or a Plugfest, whatever they're called these days, in kind of a long time. So at some point, hopefully in the not too distant future, we should do one of those and get that together. And you'll hear some more about that on the next slide. And then also, based on what I just said in the previous slide, like we, the working group, as we're working on the TSR document, which has been adopted, I guess, we should figure out how much implementation advice we want to give and what's relevant and what's sort of we can leave up to the implementer. By the way, if anybody has questions, feel free to interrupt. SRP replication basically has been blocked on TSR for a while. I think at this point TSR is fairly mature, but you saw the previous slide. There's still some work to do there in terms of implementation. But so one thing that's gone on with TSR is that as we've been learning from the TSR implementation, we've realized that it's not always safe to have, let's say, version 1 and version 2 kind of cooperating together, because we've refined the behavior of TSR, and the previous implementations were a bit broken, and having them coexist on the same link was actually causing packet storms. So one of the things that we ran into recently is that we need to have a way for SRP replication to cooperate in terms of making sure that everybody is running versions that are mutually interoperable. Doesn't necessarily have to be the identical same version, but they shouldn't have known issues interoperating. So quite a while ago, actually, we added a version number to the session message, but the way we implemented it was a bit naive and it didn't work at all. And I didn't realize that until we tried to use it. We recently added this functionality that that we actually try to arrange for the most recent version to win. And we did that not so much because we actually desperately need the most recent version to win, as that generally speaking, the most recent version is more likely to be able to win than a previous version in terms of its behavior, because the previous version is something that's already shipped, right? Like its customers already have it, it's installed in their house. We can't we can't update it, right? Except by getting them to do a software update, which apparently they didn't do, or we wouldn't have this issue. So the new behavior is that whoever identifies it, whichever implementation identifies itself as most recent, will try to force out the lower version implementation, and that does work. It prevents these sort of packet storm issues. So we're reasonably happy with this, but it feels a little weird. So I'm presenting it to the working group partly to see if anybody wants to criticize that. Ideally, once we're done, once we've actually gotten to, once we've published the SRP replication document, which I think is still a ways out, we shouldn't run into as many issues as this, but we might rev the SRP replication document because we ran into something that we decided was important to fix, in which case we still might want to rely on this mechanism. So I think having a mechanism like this is kind of important, and so that will be something I think I would like to add. Okay, advertising proxy. So I think 1 or 2 IETFs ago, we did a fairly significant revision of the advertising proxy draft that made it a little bit less sort of DNSSD specific and more like transparent. And I think that was an improvement in terms both of understandability and correctness, but we haven't actually implemented it yet. And as far as I know, no one else has either. So that's what's kind of holding us back on advertising proxy right now. I think the document is decent. There's probably things to do about it, but it's not been the thing that we've been focused on recently because, like, TSR was obviously, we were actually experiencing headaches as a result of the problem that TSR was there to solve, and also as a result of TSR itself. So we needed to prioritize that. But at some point, we should get back to advertising proxy because it's been on our to-do list for a long time. We've already been talking about doing IPv6, like sort of snack related and also like multi-homing related work in the Madrid hackathon. The people who I think would wind up working on advertising proxy like me are the same people that will be doing that. So I don't think we have time to do this in Madrid, but I'd really like to get to it soon, maybe in, what's the next one? Vancouver or Montreal? Yeah, so maybe in Montreal we could do a hackathon on this. We'll see. So that's all I got.
Any comments? Okay, thank you, Ted.
Yep.
I wanted to mention Ted also had it in a side comment. So we adopted TSR just a few hours ago. So I pushed the button. It's adopted now.
So the final presentation is from Gautam.
Okay. Looks like I'm in the unfortunate position in being the last person between you and drinks and food. So I promise I'll keep it short. There are seven slides, including the title slide, that stand between you and drinks. So let's do this. Okay. So the goal of this draft is supposed to be an informational draft about how would we use SVCB and HTTPS resource records to enable services to advertise endpoint configuration properties. And specifically, I think the one endpoint configuration property that we're interested in is ALPN. So allowing services to indicate whether they support H3 or H2. So basically, how does SVCB and HTTPS records fit in? In a normal service discovery workflow, we would have PTR records to enumerate all of the services, followed by an SRV and TXT records query for a specific service, followed by AN quad A. And what this document essentially says is that alongside the AN quad A, you can do the SVCB and HTTPS records query. There are two questions that remain, like should we send an SVCB or an HTTPS query? Because I've used a slash everywhere. So do we send an SVCB or do we send a HTTPS? And the second question that remains is what would be the queue name associated with the query? So in terms of whether we send an SVCB and HTTPS, it depends on the URI scheme that we expect. And I understand that this is probably not the very DNSSD thing. This is a lot of things that we're inheriting from how SVCB specifically does things. So roughly speaking, if a client expects the URI to be HTTPS, then we use the HTTPS resource records. But if we don't expect HTTPS, then HTTP, then we use SVCB. The other thing that we also make clear in the document, if we expect no URI scheme in order to connect to the service, then we should not use SVCB HTTPS queries. Okay, so the second thing that remains is what is the queue name that we need to use. And in this case, we follow RFC 9460 to hang off the SVCB records of the host name. And this is an explicit decision to hang off the host names, the SVCB record of the host names and not of the service instance name. And this is specifically so that a lot of the APIs in the system are just given this URI, and it would have been better for us if we could have hung it off the service instances. But as we go down the system, we lose this rich semantic of service, and all we are left with is URI, and they are going to use RFC 9460 to construct the SVCB. So as unfortunate that it is, we are going to, I think it makes sense for us to do SVCB name construction using the RFC 9460 standard. Specifically, we are going to do port prefix naming. And if we expect, so there are two things in an SVCB record. It's the port followed by the scheme, followed by the host name. There are a few more nuances there. If we are using an HTTPS resource record and we expect the URI scheme to be HTTPS, you don't use _HTTPS. If the port is also the default port, you don't use the default port. So there are a few of those nuances that we also inherit because of how SVCB and HTTPS resource records were sort of designed. One of the things that was brought up to us was like, why not just use TXT records? So when we do the SRV query, we also do the TXT records. And we sort of went back and realized in 6.6.3, the goal of the TXT records is to provide additional data that is service dependent. And this is more from the service. This is supposed to be application data that is more application specific. And since the properties for the things that we are looking for are for the system that essentially talks about how do we make this connection to this service, which is more system oriented. And since SVCB and HTTPS resource records are used for this exact purpose in non-DNSSD settings, we felt like the SVCB was a good fit here. over the last week, we have had a lot of conversations with folks, and I think there are a couple of things that we need to sort of think about in our next version. So the first is, how does this interact with TEDs, like the SRP? And basically the thing that we are sort of thinking through would be, how does it interact with the trust model for the service registration proxy? I don't think that would fundamentally change what queue names we query for, but I think it's something that we need to sort of at least talk about and talk about why we are making the decisions to like hang things off the host name and how exactly it would interact with SRP. The second thing that I think we need to sort of think through, how we would include the SVCB records, if at all, in responses. So one of the things that RFC 663 allows us to do is include the A and quad A records when responding for an SRV record. Like when you're sending the SRV record, you can also include the A and quad A with it. This reduces round trip times, but if we are now going to have this SVCB record, you're going to have to make a new additional query for the SVCB. So is there a good mechanism by which we can sort of list out which exact SVCB record to include that will essentially bypass a lot of the round trip time concerns that we might have with this? And finally, there was some question about what kind of trust establishment model we would have. Though I don't necessarily think that would be part of this document. Like the TLS pick in the TLS working group seems like a good fit for this. Yeah, I think those are the things that we have sort of got from conversations with with different folks here. If other people have some feedback, that would also be appreciated. Thank you. I promised it would be short, so.
Tommy Jensen, I think the draft is useful. In line with your middle bullet there about bundling A and quad A records in responses, the draft currently mentions that there may be IPv4 and IPv6 hints without saying anyone should use them. I would drop mention of those at all and have the client instead request those, and as multi-queue type progresses, even suggest doing that, because there's multiple stages where there's parallel queries of multiple types, and the whole flow does have a lot of queries by like the way it is, but that'd make it more efficient. But I drop hints altogether. We went through this with discovery of designated resolvers, parentheses 9462.
Okay.
May as well just save you the draft RTTs. Minor note, section 4 does not walk through the steps in chronological order in terms of execution time, and it made it slightly hard for me to follow, but that's a minor, just rephrase consideration.
Okay. Noted. We will work on that. To your point about, so like drop IPv4 hints, and then I'm just making sure that I remember. What was the second thing?
Wow, what was the second thing? Oh, being able to use multi-query type wherever you have multiple at the same, like in parallel.
So with multi-queue types, we were actually thinking about it. The way we choose, the way we have to construct our SVCB query and hang it off the host name, I thought precludes us from using multi-queue type.
Yeah, you cannot do it all at once. There's at least 2 steps there, right? Because you can get a different host name from the SRV. Can't do that. But anywhere where you want to be able to find A and quad A at the same time, I'd put that in there, because otherwise right now there's like 6 or 8 total queries, and even if you can get that to 4 or 5, that's a big deal.
Okay, noted. Thank you.
So you said you can't use the additional section. I don't understand it, because RFC 9046, he says that a kind of responder can put in the additional section with A and quad A. Why can't you use it here?
In the A and quad A, like include SVCB records, is the are you talking about the second bullet point here?
Yeah.
So I think the problem that we are sort of we're sort of anticipating is when you have multiple services with multiple SVCP types, where there might be multiple things that match. So, okay, SVCP records might not have, if you're on the default port, you might not match, you don't have to put the port prefix in there. In absence of the port prefix, do you sort of return multiple SVCP records? So I think it's more along the lines of, are we confident that we can find the right SVCP record to return in presence of multiple SVCP records? And I think we can, but it was just a thing that we wanted to flag to make sure that if there are thoughts around that, that we can get to those.
Right.
But you're right, we can do it. It just, can we be confident that we can return the right SVCP record?
Stuart Scherzer from Apple. I think you know that by now. But I get yelled at if I don't say my name at the microphone, so I have to do it. Just following up to Ralph's point or question, the challenge here is that when a recursive resolver or an authoritative server or a multicast DNS responder receives a query, it has to do some logic to work out what additional records it might send. And for SRV right now, it's pretty simple. You look at the target host in the SRV record, and if that's got address records, you throw them in the additional section. That doesn't mean we can't do this, but we need to write down what the rules are, and then we may have to wait many years before that shows up in your home gateways and all the recursive resolvers that exist in the world. But we can definitely do that. And Ralph, if you want to propose some text for like, what are the rules for how a general recursive resolver works out what are the right additional records to send? As you said, it might be HTTPS, it might be SVCB, it might have a port prefix on it, it might not. Off the top of my head, I don't think I could concisely say what the rules are, but if we can write it down, then we can write it, and maybe if that gets into open source implementations, eventually it'll trickle through to real implementations.
Thank you. Yeah. So I think, as Stuart summarized, I think the issue is how do we concisely summarize the rules for which when to include the SVCP and HTTPS records, because it could be SVCP, HTTPS, maybe a port prefix, not a port prefix, maybe the scheme, not the scheme. So there are quite a few nuances there. Okay. Thank you.
All right. Thank you, everyone.
3 minutes before, so now you can have drink.
All right. So that concludes DNSSD in Bangkok. It doesn't know. Area director says it's not closing the working group. Definitely not doing that. Concludes the meeting. Thank you, everyone. Hope you've enjoyed it, and we will. Yep. Thank you, Sadhu, for taking notes. And please comment on the list with all of the interesting topics that we have just covered. Thank you. Have a good trip.